All right, let's get right into it. Deep inside the world of high-tech manufacturing, there's this invisible battle happening, like every single day. It's a quest for absolute perfection, because even the tiniest mistake can lead to huge problems. Today, we're going to pull back the curtain on that quest. And this really gets to the heart of the mystery, doesn't it? I mean, how on earth do you find a microscopic crack or a tiny little warp in a piece of metal that, to you and me, looks totally perfect? This is the exact problem that keeps engineers staring at the ceiling at night. You see, in fields like aerospace and automotive, we're not just making widgets. We are building the very things that fly us through the clouds and drive us down the highway. The sheet metal parts are basically the skeleton for all of it. And that skeleton, it has to be perfect. There's just no room for error. So, every good story needs a villain. And in ours, it's the hidden defect. And we're not talking about some big, obvious mistake. No, these are the sneaky ones. A little bit of spinning in the metal, a tiny crack, things that even a highly trained human inspector could easily miss. They're expensive, they can be dangerous, and they're the absolute enemy of quality. But you know how it goes. Where there's a villain, heroes are sure to follow. To fight these invisible enemies, we need a whole new breed of detective. We need digital detectives that can see in pixels and think in algorithms. And thankfully, a new generation of them is answering the call. So, meet our first contender, SSIM, which stands for Structural Similarity Index. The best way to think about this one is as the wise strategist. It doesn't just stare at pixels one by one. Instead, it looks at the whole picture. The overall structure, the lighting, the contrast, kind of like our own eyes do. It's designed to understand what it's actually looking at. And our second contender is NCC, or Normalized Cross-Correlation. Now this one is the pixel-perfect perfectionist. It's got an unbelievable eye for detail, matching patterns pixel for pixel to find the absolute tiniest flaws. But, and this is a big but, that super sensitivity can be a weakness. It can get sidetracked by something as simple as a minor scratch that doesn't really matter. So you can see we've got two totally different ways of thinking here. On one side, you've got SSIM, the strategist, who's analyzing the whole structure, seeing the forest and the trees. And on the other side, you've got NCC, the perfectionist, who's meticulously checking every single pixel. Two very different strategies for hunting down the same flaw. And of course, what's a showdown without the reigning champ? In our story, that role is played by MATLAB. It's the seasoned veteran, the powerful and reliable tool that's been the industry standard for a long time. It's the benchmark that our two new heroes have to beat. All right, so the stage is set, our contenders are ready. It is time to throw them into the gauntlet. The researchers set up a really tough series of tests to see which of these algorithms could actually rise to the challenge and find those hidden flaws when it really counted. The way they tested them was actually pretty straightforward. First, you start with a perfect digital model. That's your reference image. Then you snap a really clear photo of the part that just came off the assembly line. That's your target image. And the algorithm's job? To play the world's most high-stakes game of spot the difference and highlight anything and everything that doesn't match perfectly. And believe me, this was not some walk in the park. The algorithms had to face 3 different trials, each one more complex than the last. They started with the pretty simple edge design, then moved to the more intricate leaf design, and finally, the really complex tree design. Each one was created specifically to push these systems to their absolute limits. So, after all the tests were run and all the data was crunched, the results were in. It was the moment of truth. Which of our digital detectives would come out on top? Okay, let's look at the numbers. In the first big test, contour inspection, NCC, our perfectionist, scored a very respectable 94.79%. The old veteran, MATLAB, did just a little bit better at an even 95%. But then, look at this. Our strategist, SSIM, just leaps ahead with a commanding 98.19% accuracy. Wow. And if you thought that was impressive, check this out. When the test got even harder, when they had to detect specific features inside the part, not just the outline, SSIM pulled even further ahead, peaking at an incredible 98.39%. I mean, that is a decisive win. So the big question is, why? Why was the strategist so much better than the perfectionist? Well, the researchers spelled it out pretty clearly in their paper. SSIM won because its approach is more, well, human. It's comprehensive. It was literally designed to see things the way we do, by understanding the whole structure, not just the tiny little pieces.
Now, this is more than just a cool result in a research lab. This victory, it has some really big implications for the future of how things are made and for the quality of the stuff we all depend on every single day. And here's why this really matters to everyone. This champion algorithm was built using Python, which is open source. That means it's super cost-effective. This isn't some top-secret billion-dollar system. It's technology that smaller businesses can actually get their hands on, which basically democratizes high-level quality control. At the end of the day, that means more reliable products, way more efficiency, and just better, safer stuff for all of us.
So it all leaves us with this one big, exciting question. We started this whole journey trying to find a flaw that we couldn't even see, but in the process, we ended up finding a new way for machines to see perfection itself. It just makes you wonder, now that our tools have an eye for quality that's as good as, or maybe even better than our own, what incredible things are we going to build next?